This is your Daily 10, non-calculator video 9. Make sure you pause the video and attempt the questions before you actually watch the solutions. So here's your first question. This question is all to do with area of a semicircle. Well, if we start off with just area of a circle, if you remember, area of a circle is pi r squared. So to work out a semicircle, what we would need to do is half that, so divide it by 2. So if we put in the information that we've got, the radius is 6, we would get pi times 6 squared, then don't forget we need to divide by 2. Well, 6 squared is 36, so pi times 36 divided by 2. 36 divided by 2 is 18, so it would leave us with 18 pi, and that it's the solution that we would circle. Here's your next question. So for this question, we are comparing the size of fractions. We know to compare fractions, we would have to make sure that they all have something in common, and that's the denominator. So for this, we are going to try and find a common denominator for fifths and eighths. Easiest one we've got, lowest common multiple of 5 and 8 is 40. So we're going to change each of these fractions and the half into a fraction out of 40. So 2 fifths. We've multiplied the denominator by 8 to change it into 40. So we times the top by 8 as well to give us 16. Doing the same to 5 eighths. To change that one to be 40 at the bottom, we've times by 5 at the bottom here, so we times by 5 at the top to give us 25. And then lastly, we do the same with the half because that's what we're trying to compare it to. Changing that into something over 40, we've times the bottom by 20, so we do the same to the top. And we are trying to find which of these two fractions is closest to 20 over 40. Well, this one is 5 away, this one is 4 away, so 2 fifths must be the one that is closest to a half. Here's your next question. Here we need to try and show that this little calculation here always gives a negative answer or maybe a positive answer. We need to try and prove whether or not it's correct. Well, the first thing I would do, the square root of 98.5, bearing in mind this is a non-calculator paper, I can't do that in my head. However, we do know that the square root of 100 is 10. So we know that the square root of 98.5, because 98.5 is a little bit smaller than 100, must be smaller than 10. Now, if we use that piece of information on this little calculation up here, we actually get that something that's smaller than 10, take away 12.1, no matter what that number is, if it's smaller than 10, taking 12.1 away will always be negative. So we know that the top of the fraction must always be negative. So no matter what happens, if we divide then by a number at the bottom, by minus 0.8, because we're dividing by a negative number, it will always be the case that we have a negative divided by a negative. And as we know about the rules of negative numbers, if you divide a negative by a negative, the answer is always positive. Therefore, in no situation could this be negative. So is he correct? No. Always positive when you do a negative number. Divide by a negative number. Here's your final question. Now this question brings in a lot of the third topics that you'll have seen. We've got 3 separate elements here. Examiners are very keen for you to try and show every element of working nowadays, And for 4 marks, we're going to have to make sure that we do that. So what I'm going to do is take each of these 3 bits, one at a time, and try and change it in something that's a little bit more usable. Now it's given us the clue that the final answer, when I calculate all of these and do the calculations, is going to be in the form a root 2. So it's going to have something with root 2 at the end of it. So if we start with 26 over root 2, now it doesn't tell us to do this, but we know that we don't like to have surds at the bottom of a fraction. So we know at this point what we have to do to try and remove that is we multiply top and bottom by whatever the surd is. So because I'm timesing the same, top and bottom, it doesn't actually change the fraction, keeps it equivalent. So here we would get on top 26 times root 2, so 26 root 2. On the bottom, root 2 times root 2 is the square root of 4. But the square root of 4 we can actually do. So on top, I'm just going to leave it as 26 root 2. Square root of 4 is 2. And at this point we've just got one more simplification we can do. 26 over 2 is 13. So this actually comes out as 13 root 2. I'm now going to do something similar with the next element. So 12 over the square root of 18. I'm going to times top and bottom here again by the square root of 18 because we don't like the fact that we've got this surd at the bottom. So we're going to rationalise it. If we do that, we get 12 root 18 on top. Now on the bottom, if you're looking and thinking how do we do root 18 times root 18, we can actually cut out that step. If you look at the one above, root 2 times root 2 gave us root 4, and that is just 2. So actually when you times the same square root together, so times it by itself, it will just equal that number without the square root. So root 18 times root 18 actually is just 18. Now the next thing I'm going to notice here is actually the square root of 18 we can change, we can simplify that. That's quite a large number, and what we can do is actually split that down. So root 18 I'm going to split into 2 separate surds. I'm going to put this over 18 just so I don't forget it for later. Well, 18 is actually the same as root 9 times root 2. So simplifying again here a little bit, that would give us 12. Root 9 is 3. Square root of 2, I'm going to leave that in. It suggested that at the start of the question. And don't forget the 18 at the bottom. Now just neatening this up, we get 12 times 3, well that's 36. So we get 36 root 2 over 18. There's one final step of simplifying I can do here. 36 over 18 is actually 2. So finally this comes out as 2 root 2. The third and final part, so 2 root 50. I'm going to do some work with this one now. Now this one we don't need to rationalise, it's not a fraction. But what I do notice about this one is that root 50 can be split into 2 separate surds. Now we've already got the hint that it's going to have to be root 2, because that's what we're changing all of them into. Therefore this one would have to be 25, because 25 times 2 is 50. Simplifying this, that would give us 2 times square root of 25 is 5 times root 2. And then just neatening this up, we've got 2 times 5, so this comes out as 10 root 2. For our final step, we now just need to combine all 3 of these answers. So it's said up at the top we need to do 26 root 2. Well, that was 13 root 2, so 13 root 2. Take away 12 over root 18. Well, that came out as 2 root 2. Take away 2 root 2. And then add on 2 root 50. So add on 10 root 2. Now when you're adding and subtracting surds, you can't actually do anything with the surd. It is only the number in front that we're going to be changing. So 13 take away 2 is 11, plus 10 is 21, So this altogether would give us 21 root 2.